Now that we have nav meshes, let's talk about the process of actually creating paths based on nav meshes. And the benefits that nav meshes give us when we're actually generating paths. Now, during this, or in this system, when we have nav meshes, we essentially end up with something that looks like this. I'm just going to create a series of different meshes that kind of represent what our world looks like. So here's a series of meshes, which may represent a world with just like, 3 rooms, essentially, that our AI can move between. In a system like this, our graph would look something like this, where each of these nodes are representing one of these meshes. The connectivity between them is represented by the overlapping edges, right? So these are connected, and those are connected, right? Now, a couple things to note. The first is when we are using this underlying graph data to calculate paths, that path that it's giving us is only telling us how to get from one position to another based on the meshes that those nodes represent. What do I mean by that? Well, if these nodes, I'm going to label them here, A, B, C, D, and E. If I want to go from a position that's down here on E to a position that's up here on B, the first thing that I would do is I would run something like A star or a search algorithm that says I want to go from this node represented by E, which is the one I'm currently standing on, to this node represented by B, right, which is where my goal is, my goal position. And so I need to do first an pathfinding algorithm between E to B, right? So step 1 is I have to run that pathfinding algorithm from E to B. Run a pathfinding algorithm from the start node to the end node. This would generate me a path that would probably look something like E to C to B. This would tell my AI, if you want to move from your current position, that what you should do is move from E onto C, and then from C, move on to B. Great. This is what A star would return to us. The next step after that is to figure out how to walk along that path, right? Or smooth the path based on the meshes. This second step here is where you have a lot of flexibility as an AI developer. Our AI could run all around this mesh on E and do whatever it wants, and then move on to C and run all around this mesh on C and do whatever it wants, and then run over here to B and do whatever it wants on B until finally it reaches its goal. The exact specifics of this path and how it follows along this path and how this path is smoothed is entirely up to you. If this is something like a car, you're going to want this thing to take nice wide turns and probably apply brakes and gas, and you want it to behave like a car. If this is something similar to a person, you might want to just have them walk in straight lines and then go to sort of these corners between the polygons. That's sort of how we walk, is in these sort of optimal patterns where we're getting really close to the corners or edges of rooms and doorways and stuff. If I'm walking side by side with someone else, maybe I want to leave them enough room. But as long as I'm moving from mesh E and then going to mesh C and then going to mesh B, I'm going to make it there. I'm going to get to my final position. By default, the basic path that this would give me would be to move from my current position to the center of E. And then how do I transition from E to C? Well, I could do it in a few ways. I could move to the position here, which is the corner. I can move to this position here, which is another corner, or I can move to this center position. Let's assume that's the case here. So I'm going to go from my current position to the center of where I am now, potentially to the center of the connecting edge. And then from there, I can either move to the center of the polygon, or I could go directly to the next edge. I can move anywhere in this polygon. So let's say I move right to the center of the next edge, right? So this is the center of the next edge that connects the two. And then from there, I can even just do a straight line to my goal, right? Or I could have moved to the center, completely up to you. This method of path smoothing and which positions you go to is entirely your own design. Some common strategies include moving to the center of edges, moving to the corners of edges based on the closest corner to your next position. Some move in straight lines or pick random positions on these edges. One thing that you do want to avoid, though, I will say, is, and it's very common to see something like this in games, is that when you end up with a bunch of triangles that sort of represent your walkable spaces, you may actually end up generating some strange looking paths. And what do I mean by that? If you only walked to the center of each of the connecting meshes, and you were walking from this position to this position, you would end up generating a path that looks similar to this. The center, 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 then to your center, which can actually look really zigzagged. If you've ever played a game and you've been walking down a hallway and your AI actually does like a zigzagging thing as you're following them or they're following you, this is exactly what's happening. They're moving to the centers or they're moving to some predetermined position on their navigation meshes without doing a nice smooth path. So the final thing to do here is smooth your paths based on this additional knowledge that you have about connected edges and these meshes, and how you do so is entirely up to you based on what that AI is in your game.